If I look at electrochemical cells, electrochemische cellen, the minute you hear the word chemical, it means it can be either or. Electrochemical doesn't tell me which one it is. It just tells me that I'm making or using electricity. So for electrochemical cells, elektrochemische cellen deel in twee. Hulle is of voltaic. I've circled the V on purpose. The alternate name is galvanic. It's got a V in it again. Or they are electrolytic. Now, he asked me earlier about swapping my terminals around. Nou is dit weer lekker vir die Afrikaanse kinders om te onthou, so the English people can look at how they can remember it. Electrolytic is in Afrikaans elektrolyties. Kyk, ek gaan net hoe skryf ek dit en ek gaan dit as prins doen, dat jy het onthou, ek gaan dit elke keer doen. Elektroly. Sien jy het lyk soos 'n sel? Dis. Always, not sometimes, always, altyd, is die positiewe terminaal aan die linkerkant en die negatiewe terminaal aan die regterkant. The examiner can swap them around to try and confuse you, but you never swap them around. So the theory, when you learn it, you always put the positive terminal on the left and the negative terminal on the right, always. What's the difference between the two? In a voltaic or galvanic cell, the redox reaction is spontaneous. In an electrolytic cell, the redox reaction is non-spontaneous. Ons sê nie spontaan nie. So galvanies met die V is spontane redox en elektrolyties is nie spontane redox. And from what I've used here to explain it to you there, you can see it. Daar's 'n sel. Ek sit energie in. Daai sel sê vir my, I use electric energy and turn it into chemical energy. I force a chemical reaction to take place. Ek dwing 'n chemiese reaksie vind plaas. Terwyl die redox reaksie by voltaïs, begin jy met 'n chemiese reaksie of met chemiese energie en spontaan sonder dat jy kan help word dit elektriese energie. Op die oomblik is my selfoon voltaïs, galvanies, hy werk. Daar's chemikalie aan sy binnekant wat besig is binne in sy sel om chemiese energie om te skakel in elektriese energie. Die oomblik as ek hom inprop, dan gee ek vir hom daai stroom. The minute I plug it in, I'm giving it current. And I'm reversing the process and I'm using electric energy that I get from Eskom to change into chemical energy so that I can have the chemicals back again so that it can work again tomorrow. In other words, for a spontaneous reaction, we now already know that I need a sterk reduceermiddel nodig en ek het 'n sterk oksideermiddel nodig. Nou, dit's sommer strong en sterk die mekaar. And therefore, watch my hand. We often call it the C rule. C doesn't mean like it's somebody's law. It's just a way to remember something and make it easy to remember. If it's spontaneous, it makes a C. As hy spontaan is, maak hy 'n C. Kyk my hand. Ek begin regs bo as ek 'n C maak, gaan links, kom af en gaan regs. I don't think I've ever seen anybody make a C and start at the bottom. We all start at the top. Unless you failed grade 1 or you didn't have a great grade 1 handwriting teacher. Jy begin altyd bo. So as hy spontaan is, soos julle sit, spontaan is, sal hy so omlees. As hy nie spontaan is nie, sal hy so omlees. Jy mag dit op aarde nooit in 'n vraestel vir iemand skryf nie. Dit is net 'n manier om dit te onthou. So if it was electrolytic, it's easy. It would be that way around. and you would be starting, you always have to start on the right, you always have to start with the reducing agent. So it would be a weak reducing agent, which would be reacting with a weak oxidizing agent. So that it's not a C, I'm starting at the bottom, going up and going across, definitely not a C. How do I recognize them if I look at the two diagrams? Very easy. I've given you the hint. The hint is look for a voltmeter. If it's not a voltmeter, look for a globe. Look for a cell. In other words, if they draw, they could draw something like a voltmeter connected to an electrode. In a voltaic cell, they're normally in their own separate beakers. Because they each need their own electrolyte. Voltaiese selle het elkeen sy eie bekertjie want dit sy eie elektrolyt nodig. If it's electrolytic, remember my lities, there's a cell at the top. There are the electrodes, and they share the electrolyte. There's my first difference. Easy to see. This guy must be voltaic. Voltaies, galvanies with the V in. Elektrolyties, daar's die lities. Spontaan, nie spontaan. Sterk en sterk, swak en swak. Chemie word elektries. Elektries word chemies. Selfoon werk, selfoon laai. Altyd, altyd, altyd. No exception to the rule, excepting you don't trust an examiner. You always double check them that they've drawn it properly because you know how to determine anode and cathode from your redox table. And you know that that should be that way around. If it's drawn correctly, then always on the left-hand side, always the anode. Always on the right-hand side, the cathode. Links, altyd die anode. Regs, altyd die kathode. Always, no exception, geen uitsondering. Elektrone weg van die anode af. Elektrone weg van die anode af. No exception whatsoever. En hier kom die groot verskil in. As ek gaan kyk na waar daai elektrone vandaan kom en waar hulle heen beweeg. On the electrolytic cell, die een op die regterkant, elektrolyties, weet ons daai is lank positief, kort negatief. So dit kan nie anders wees nie, that has to be the positive terminal and that has to be the negative terminal, because that's the way they're connected to the cell over there. On the other hand, if I look at it when it's a galvanic cell, the electrons are moving away and it's not connected to a cell, it is the cell. And electrons are negative. So just as much as negative electrons will move to that positive terminal, electrons would move away from something which was negative and towards positive. There's the next change. So it's strong, strong, weak, weak. It's the two beakers, the one beaker. It's the voltmeter at the top or the cells. And now it is the swap around of the minus and the plus. But always at the anode, oxidation, no matter which one it is. Always at the cathode, reduction, no matter which one it is. Always reduction, always reduction.